So I'm going to do a quick recap for the simple stuff, which is solving systems of equations by graphing and by substitution and by elimination. And I'm going to do one of each. And then there's this fancier stuff back here using matrices, but we'll get back to that, called Gaussian elimination. But this is for session 1. This is just for the simple stuff on the first page. So solving by graphing, you want to simply graph these two lines. And the way I'm going to do that is I'm going to change both of them to y equals mx plus b. So taking a look here. First, I bring the x over minus 3x both sides. Now I'm going to divide out that -4. And I get y equals double negative, positive, double negative, positive. Now I'm going to graph that. +2 on the y-intercept. And it is a positive tilting line going up from left to right. Up 3/4. Or I could go down 3/4 this way. Either way, you're going to get the same line. So that's the first line that I have in blue. Next one here, I have in red. Whoops. X plus 4y equals -8 minus x both sides. I get 4y equals -x minus 8. Divide by 4. And we get the line y equals -1/4 x minus 2. So we're at -2, and it is a downward tilting line from left to right. So up 1/4 to the left, down 1/4 to the right. And there is your negative tilting line. It's really important you do this using a straight edge. You can see where they cross is considered the solution. Solving by graphing, solution. And our solution here looks like it's going to be -4, -1. Now, what's really nice about this is you can mathematically test it. You don't have to just be dependent on how accurate you can graph. So we are going to take right here, -4 and -1 and pop it in. So I have here 3 times -4 minus 4 times -1, and that should come out to -8. We're going to check that. That's going to be -12. Negative times a negative is a positive, so that's +4 equals 8. -12, -8. -12 plus 4 does equal -8. So check on the first one. Let's check on the red as well. Our x is -4 plus 4 parentheses times -1 should equal -8. -4 plus -4, -8. Check, we know that works. So our solution set here is absolutely -4, -1. Substitution. Step 1 in substitution is to isolate a variable from one of the equations. And it's best to try to find a variable in which it's already almost all by itself, which that x is almost by itself. So I'm going to bring that down here. And I have x plus 7y equals negative 13. So you isolate the x. So now we have a definition of x as being negative 13 minus 7y. That is the definition of x. So now we take that definition of x and we plug it into the equation we did not use right there. So I'm going to take this definition, plug it in right there. So 2 negative 13 minus 7y, because we're substituting that value for x, plus 14y equals negative 26. Distribute. So we have negative 26 minus 14y plus 14y equals negative 26. Okay, so if you look closely here, you see that everything kind of cancels out because that becomes 0 and the 26 0. And so you're like, what's going on? So this is important to see it by graphing so that you can see that this is the exception to the rule. So if we were to graph right here, if we were to graph this, it would essentially be, I'm going to bring it up here so you can see it right up here and see why does this look a little wonky. Use this graph here. Just full space. All right, so let's change this to y equals mx plus b. So I'm going to have 7y it's going to be negative x minus 13. Don't know why that's not turning out very well, but we'll take a look here. Let me just come down here. You can see if you divide everything by 2 here, you see it's the same line. So the concept of a solution is that you have 2 intersecting lines and that you solve by where they intersect. So what's going on with number 4 is that it is the same concurrent line. If you were to graph this, it'd be the same line. Therefore, there's no intersection. Therefore, there is no solution, or technically infinite solutions, because they both describe the same line. That's why everything cancels. Also, in this situation, there is no solution if the lines are parallel, because by definition, parallel lines do not cross. So taking a look here, let's do one that isn't the one of the wonky ones. So let's take here, solve by substitution. I'm going to go ahead and use this one right here. So I'm going to say reorder everything. So y equals, that's going to be 8 There you go. Okay, so y equals, bring the x over, so that's 8x plus 13. That is our value we're going to use for y. We're going to plug that value of y right there. So I have 5x minus, here's the trick, that's a single entity. Make sure you get parentheses around that, equals -10. Very important. This is where students get caught, is they forget to distribute that negative sign to both terms. Select terms. I've got a -3 here. X plus 13 equals -10. That's -13. So we're going to add 13 both sides. And I have -3x equals +3x equals, if I divide both sides by -3, -3x equals -1. That's the value of x. Now we take that value of x and we're going to plug it in right here with the equation you did not use. We did not use this one right here. So we have 5 times -1 minus y equals -10. -5 minus y equals -10. Y equals 5. So our solution set should be -1, +5. What's really nice about this stuff, once again, is you can easily test it. So we are going to plug in -1 to there and +5 to there. We're going to see what happens. So 8 times -1 plus, that's -8 times -1 plus 5 equals 13. That's 8 plus 5 equals 13. 13 equals 13. Ta-da, you know you're correct. So there's your solution set. So to recap, you redefine one variable in terms of the other. Then whatever equation you use to redefine, you plug it back in, and that is substitution. Elimination. Elimination means to cancel. Elimination means to cancel. So taking a look here, your goal is to get one of the variables to completely cancel. And it doesn't matter here which one you use, but you want to try to find one that's easy to multiply out. So I already have a negative and a positive. So that's one thing you want to look for, is a negative and a positive. And you want to find one where you can easily multiply it out. So I'm going to take this first equation. I'm going to multiply everything by 2. You'll see why it's 2 in just a moment. Ready? Watch. I'm going to get 16x minus 20y. Make sure you carry every single term. It equals 52. And the reason why is that -20y is now going to be eliminated. So I cross this out. And here we are essentially adding here. So 5x plus 16x is 21x. These cancel. That's -10. -10 plus 52, that's going to be 42 positive. Divide everything by 21, and you get x equals 2. Take that variable and plug it in to either original equation, and I'm going to take that 2 and plug it in right here. So 5 times 2 plus 20y equals -10. It's 10 plus 20y equals -10. Minus 10 both sides. I have 20y equals -20. Y equals -1. So our solution set seems to be 2, -1. Never be happy with what you believe is a correct answer. Always check it. So we're going to come over here. I'm going to use that original equation, 8x. Is that a plus sign? Minus 10y equals -26. We're going to plug in 2 to there and -1 to there and see what's happened. 8 times 2 minus 10 times -1 equals, oh, that's not -26. That's just 26. That's important. 16 plus 10, 26. 26 equals 26. Ta-da! It works. So that is solving by graphing, by substitution, and elimination.